NASA says it has heard from the Voyager 2 spacecraft, which right now is in interstellar space.
Voyager 2, which NASA launched in August 1977, is no ordinary spacecraft. It's been over 47 years since it set off on its mission, and it's still making us think in new ways. Designed back in a time when modern technology, as we know it, was still just a dream, Voyager 2 has gone above and beyond, exploring realms of space that were once considered unreachable. What makes this spacecraft truly extraordinary is not just how long it's been functioning, but the distance it has traveled to. Together, Voyager 2 and its twin, Voyager 1, have traveled farther from Earth than any other human-made object. Both spacecraft have passed through the solar system and ventured into interstellar space, which few scientists thought we'd ever reach in our lifetimes. The Voyager 2 mission was originally designed to explore the outer planets. It provided us with some amazing images and lots of valuable data from Jupiter, Saturn, Uranus, and Neptune. But the real surprise came when it sailed beyond these giants into the great unknown, interstellar space, the vast emptiness between stars. And now, even after nearly 5 decades, Voyager 2 is sending back data that's transforming our understanding of the cosmos. NASA recently announced that Voyager 2 had made a discovery that scientists had thought was impossible. In the deep, mysterious realm beyond the solar system, Voyager 2 has encountered phenomena that challenge our current models of space. What exactly has this bold explorer discovered? Let's take a closer look. Before we look at what Voyager 2 has found recently, it's important to understand the environment it's traveling through. At the moment, Voyager 2 is in a region called interstellar space, which is beyond the influence of our sun. It's a place where the solar wind, a stream of charged particles emitted by the sun, meets the interstellar medium, which is a sparse mix of gas, dust, and cosmic rays that fills the space between stars. The heliopause is the boundary that separates our solar system from interstellar space. For years, scientists thought this boundary would be smooth and static, like a shoreline where the sun's influence ends and the galaxy begins. But Voyager 2 has shown us that this boundary is anything but calm. As it turns out, the heliopause is actually much more turbulent and dynamic than we ever imagined. As Voyager 2 crossed the heliopause in 2018, it started sending back data that shocked scientists. The spacecraft picked up some unexpected fluctuations in particle density in interstellar space, which challenged previous models. Instead of finding a uniform empty void, Voyager 2 picked up sudden spikes in particle density, followed by long stretches of emptiness. This suggests that interstellar space is a lot more complex than we thought. This finding makes us think again about what the heliosphere is and how it works. The heliosphere is the protective bubble created by the sun's solar wind. Scientists had always assumed that this bubble was pretty stable, but the data from Voyager 2 suggests that the outer edge of our solar system is filled with waves and ripples, potentially caused by interactions between the solar wind and the interstellar medium. These ripples could extend far beyond the sun's influence, affecting the very structure of the space around us. One of the most exciting things about Voyager 2's recent findings is how they show us what interstellar space is really like. Previously, scientists thought that once a spacecraft left the heliosphere, it would enter a relatively calm, static environment, but Voyager 2 has shown us that the interstellar medium is anything but still. It's dynamic, with constant changes in particle density, magnetic fields, and cosmic reactivity. This is a really big deal because it challenges a lot of what we thought we knew about space. The data from Voyager 2 shows that the interstellar medium behaves in ways we didn't expect. The particle density rises and falls in ways that we don't understand. What could be causing these fluctuations? That's something scientists are still trying to figure out. Some theories suggest that these variations may be the result of shock waves from supernovae that happened a long time ago. Some people think there might be unknown forces at work in the vast emptiness between stars. On top of that, Voyager 2 has also picked up an increase in cosmic rays, which are high-energy particles that come from outside our solar system. Since it first crossed into interstellar space, the spacecraft has been encountering cosmic rays. The latest data shows that there's been a notable increase in their intensity. This suggests that Voyager 2 may be passing through a particularly active region of space, where there are more cosmic rays than expected. These findings have got scientists wondering where these cosmic rays are coming from. Are they coming from a supernova in the distance, or could they be the result of other less well-understood astrophysical processes? Whatever the answer, what Voyager 2 has found is changing how we think about interstellar space and the forces that govern it. The discoveries made by Voyager 2 also have a big impact on how we understand our solar system's place in the galaxy. The heliosphere, which was previously thought to be a clear and distinct boundary, is now seen as a much more dynamic and turbulent region. This could change how we think about how the solar wind interacts with the interstellar medium, and even how space weather affects planets like Earth. Space weather is caused by interactions between the solar wind and the interstellar medium. It can produce shock waves and other disturbances that travel through the solar system. These disturbances can affect things like planetary atmospheres, magnetic fields, and even the climate. If we can understand how the interstellar medium behaves, we can use that to predict space weather events more accurately. That could help us protect Earth from harmful solar storms in the future. What's more, the data Voyager 2 has gathered could help us gain a better understanding of the boundaries of other star systems. If our solar system's heliopause is turbulent, it's likely that other stars have similarly complex boundaries. This could change how we think about how stars interact with the galaxy as a whole, giving us new insights into the structure and evolution of the cosmos. The discoveries made by Voyager 2 aren't just of academic interest. They could have real-world implications for future space exploration. As we look to send spacecraft even further into interstellar space, it's becoming increasingly important to understand the conditions of this vast and mysterious region. Voyager 2 has shown us that interstellar space is a lot more varied and dynamic than we thought. This means that any future spacecraft designs will need to factor in these challenges. Engineers will have to think about how particle density might change, more cosmic rays, and the chance of bumping into shock waves or other disruptions. These factors could affect how spacecraft are designed, the types of instruments they carry, and the strategies for communicating with Earth over long distances. On top of that, Voyager 2 has been going strong for almost 5 decades, which is proof that its design is built to last and shows how clever the scientists and engineers who built it were. Future interstellar missions will need to build on what we learned from Voyager. They'll have to create spacecraft that can survive for even longer in the harsh environment of deep space. Voyager 2's success also makes us think about the future of human space exploration. Although Voyager 2 is a robotic mission, its findings will be vital for preparing humans for long-duration space travel. As we look to send astronauts to Mars and beyond, we'll need to figure out how to keep them safe from the dangers of cosmic rays and other space hazards. The data from Voyager 2 could help scientists come up with better shielding techniques and other protective measures to keep astronauts safe on future missions. The discoveries made by Voyager 2 could also have an impact on other areas of science and technology, as well as space exploration. For instance, cosmic ray research is key to understanding high-energy particles, which are vital for fundamental physics. Cosmic rays can also affect biological systems, which has implications for fields ranging from medicine to material science. The data from Voyager 2 could help us understand better how high-energy particles interact with matter. This could lead to new developments in areas like radiation therapy or the creation of materials that can withstand extreme environments. The spacecraft's findings could also help scientists understand better how cosmic rays affect planetary atmospheres. This could help us learn more about the role these particles play in climate and atmospheric dynamics. On top of that, Voyager 2's discovery of the turbulent nature of the interstellar medium could have implications for our understanding of star formation. Turbulence is a big factor in how gas and dust clump together to form stars. Voyager 2's data offers a rare insight into how these processes happen in interstellar space. This could help scientists improve their models of how stars and galaxies form and evolve over time.
As Voyager 2 keeps going deeper into interstellar space, it shows us what long-term scientific missions can achieve. In today's fast-paced world of rapid technological advancements, Voyager 2 is a great example of the value of patience and persistence. For almost 5 decades, it has been gathering data, and its most significant findings are only now being revealed. The success of Voyager 2 also shows the value of investing in long-term missions. While many modern missions are designed for short-term exploration, Voyager 2 has shown that some of the most profound discoveries come from long-duration missions that continue to collect data well beyond their original goals. As we look to the future of space exploration, it's clear that Voyager 2 will continue to inspire scientists, engineers, and space enthusiasts for years to come. It's still got a long way to go, and who knows what new discoveries are waiting to be made in the vast unknown of interstellar space. One thing is for sure: the legacy of Voyager 2 will live on, not just in the data it has collected, but in the spirit of exploration it represents. It has shown us that the universe is far more complex, beautiful, and mysterious than we ever imagined. As long as Voyager 2 keeps sending those faint signals back to Earth, we'll be listening out to learn more about the great unknown.